Alright, so today we're naming ionic compounds. And naming ionic compounds, like I said in other videos, is pretty easy as long as you know the name of the anion. Right. So that's why I kind of made the other two videos on monoatomic anions and polyatomic anions. So hopefully those helped. There are a lot of polyatomic anions, so maybe that video didn't help as much. But as I said, go search some stuff up on Google and memorize a bunch of them. But anyway, when we name ionic compounds, we usually, well, not usually, we just write the cation name followed by the anion name, right? So I guess for our first thing, NaCl, I guess it would be a good idea to figure out what our cation is and what our anion is, right? So let's see here, and usually the metal is the cation, so we have Na right here in front, right? So that has to be our cation because it's a metal ion. And also, FYI, cations are usually written before the anions in these formulas, right? So Na is in front. Na is also a metal, group 1 metal. So we know that's a cation for sure. And since it's a group 1 metal, we know it has a +1 charge in ionic compound. And Cl, right? Cl needs to have a -1 charge, right? Since the anion. Oh, we also know there's a chloride anion. That thing exists and it has a -1 charge. So I'm looking for double confirmation, right? We got that. So yeah, we have our Na plus cation and our Cl minus anion. So we know how to name the cation. We just write the element name, right? So sodium. And our anion name, that's our tricky one. But we know Cl minus is a monoatomic anion, so it probably ends with ide. And it does, because it's chloride. So that's our anion. So that's our anion name. That's chloride. So our total name for NaCl is sodium chloride. Big surprise. You should hopefully know that by now. At least if you've seen that meme on YouTube about Jimmy Neutron or something. But whatever. So let's see here. Second compound, LiBr. First things first, find the cation, find the anion. So Li is our cation, it's the metal, it's also written in front. And it's a group 1 metal, has a +1 charge, right? Let's see here, Br. Br is our anion, we know bromide is a thing. Also Br would want a -1 charge, right? And it's written at the end too, right? So let's see, cation and anion. So we write our cation name first, so that's just lithium. And then write our anion name, Br minus, so that's just bromide. So our overall name is lithium bromide. And let's see here, CaCl2. So Ca is a group 2 metal, so it's going to lose 2 electrons, so it have a 2+ charge. Now Cl2 isn't a polyatomic ion, actually it's 2 Cl minuses, right? So each Cl has a -1 charge, so 2 of them make a -2 charge to balance everything out. And for these cations where the charge is always known, like the group 1 and group 2 metals, we can just directly write calcium. We can just directly write the element name. So we have calcium chloride, because chlorides are anion, we have 2 of them. Alright, now let's see here, this one. We know K is a group 1 metal, it's written in front, it's the cation. So it has a +1 charge, and we've seen MnO4 before, right? MnO4 is a polyatomic ion with a -1 charge, right? So we just do as normal, cation name, so potassium, we write potassium, and then permanganate, I just have permanganate anion, so permanganate, that's a long name, right? Occasionally you could get away with writing potassium pomegranate, assuming the person you're talking to has ever seen potassium permanganate. Because potassium permanganate is usually a red liquid. Well, in potassium permanganate solutions usually like deep red. It looks like pomegranate juice. So let's say potassium pomegranate, you could get away with it sometimes. So here we have MgOH2. Mg, group 2 metal, as a cation, forms 2+ charge. And OH minus, right? OH minus, okay, well I just gave it away. OH is an anion. It's a common polyatomic anion with a -1 charge. And we have 2 of them to make a -2 charge to counter that +2 charge, right? So we go with magnesium hydroxide, right? Cation name, anion name. You don't need to write dihydroxide or dichloride here, because ideally when you give this name to someone who actually knows chemistry, they'll be able to know the charge of calcium and know the charge of chloride and be able to figure out that, all right, we need 2 chlorides, right? And be able to write CaCl too. So ideally the person that you tell these names to knows some chemistry to be able to write the formula. That's why I don't need to write chloride and dihydroxide and stuff like that. Alright, this is interesting. Iron, we have iron here. Iron's a transition metal, so we kind of don't know its charge. But we know we have 3 fluorides. Each fluoride has a -1 charge. So 3 of them gives a total of a -3 charge. So that means if we have one iron here, it has a 3+ charge, or a +3 charge, whatever you want to call it. Right? My goodness. Okay. This is a 3+ charge, right? And each F has a -1 charge. So when we have cations that we don't know the exact charge of, we write the element name like normal, but in parentheses put the charge in Roman numerals, usually. So iron 3, and then I'm just trying an iron name. So fluoride. Alright. Now our last one. This we're making use of our polyatomic cation, one of the few that you'll be taught, I think. Don't quote me on this. Right? So this is our ammonium cation, and NO3, we know this is our polyatomic anion, -1 charge, right? So +1, -1, they cancel out, that's good. So we have our ammonium cation, we write ammonium, right? Ammonium. Then we have our NO3 minus, our nitrate, right? So we just put an anion name, so nitrate. And we all know what happened with ammonium nitrate a while ago. If you don't know, it's ammonium nitrate's explosive, right? I'm not trying to tell you to do anything, but like, it's a good thing, right? It's a good to know that it's an explosive. So like, if you have like a ship full of ammonium nitrate, right, that's what caused the explosion in Beirut. So pretty dangerous stuff. It's also a good fertilizer, so that's also cool. So this has been naming ionic compounds, simple ionic compounds, and the really hard part is just naming the anion. But if you can do that, then naming the compound isn't too bad. So really not that bad, and stay tuned for more cool stuff.